it was easier to have multiple agents, but much more stupid than one agent, really intelligent, doing a lot of stuff and deciding which tool to use. They are selling you all of these AI editors as AI coding assistants, but at the end of the day, who is the AI assistant here? I am the one who only changes like one line of code.
You sound like you're having identity crisis.
Yeah, it's a pure identity crisis. Yeah.
Oh, I never seen it this way, man. You really ruined it for me. Oh my God. I will never program the same.
It's much better to generate very specific tasks, to task the LLM with very specific goals, because otherwise it's going to get crazy. It might generate crazy statement that deletes everything.
For somebody who doesn't know you, can you maybe tell a thing or two about yourself?
For sure. Well, first of all, thanks so much for having me, Serop. It's a pleasure to be here. I think you are doing a really nice work with your podcast, and it's a pleasure to be here.
Thank you so much.
As a guest. About my content, well, let's say that like 7 months ago, I started creating videos for the Neural Maze for the YouTube channel. By the way, the Neural Maze has a meaning. I mean, it has an intention. It tries to translate the metaphor that, or at least my feeling when I first came into this field, that everything is like so overwhelming, like a labyrinth, like a maze, so many names, frameworks, libraries, etc. So I tried to make that clear in the title, but I don't know if I managed to do it. But
you did.
That's the reason.
I can totally relate.
Yeah, it's the reason behind the name. And I started posting some content on YouTube. I started with agents because 6 months ago I became really interested with AI agents and GenAI, and I started posting some content about it. And I realized that people loved the content. I mean, they were really interested in knowing more about agents, about AI in general. And that's the reason why I also started posting more content in LinkedIn. Right now, I post content on a daily basis, which sometimes is hell, but I try to be on schedule. And on Thursday, the past week, I started my newsletter, in case you also want to check it. It's basically the same that I'm posting on LinkedIn, but written and in your email, basically. And that's basically me. Apart from this content creation phase, I also work as a machine learning engineer for a company in UK, and I'm focused. My expertise is in recommender systems and personalization, which is really cool because there are a lot of synergies between GenAI and recommendations and personalization. So it's really cool. I found a good niche here.
Yeah. Nice, man. Like I also, for people who don't know, I also work in recommender systems.
Oh,
so
really?
That's also really good. Yeah,
cool.
we develop recommender system for wholesaler. I don't know what's the English equivalent. So in Germany it's called Metro, but the UK maybe Tesco's or something.
Maybe, yeah, probably is that. Yeah.
All right. So you also work in recommender systems. You said there's like synergy between, or like resemblance between GenAI and recommender systems. What, can you maybe elaborate?
Yeah, I think that, for example, traditionally, when you build a recommender system, let's take, for example, a matrix factorization or some two towers recommender system, etc., you were focused on giving the ideal recommendation. For example, I work in retail. My company works for retail, and we generate recommendations for retailers. And we recommend to a client the best items in terms of clothes that they could possibly purchase. And what I like about GenAI, it's like a abstraction layer on top of recommender systems, because additionally to the recommendation that you're bringing to the user, you can also personalize by using, for example, a chatbot, or by using some GenAI experience or an agent that is able to chat and to adapt the way of talking, the talking style to the user, etc. So it's like agents and GenAI seems to be very related with personalization, because some of for me, of what makes attractive GenAI is basically that, the capability of make chat interfaces that can improve the personalization.
Mm-hmm. No, I totally agree. And another like really good point is the tech stack is very similar. So like I don't know, maybe you can tell us about like the system you built, but at least for us, it's always based on like some vector embeddings, and then in the vectors, like you put it in like a vector database and you do some search on top, which is basically what also like GenAI has been kind of being built on top, especially for like building like retriever augmented generation.
Yeah, rack
or
and
systems like that.
it's
Yeah,
basically the same. That's exactly. I really like that you bring this because I really like the fact that they are both built on top of embeddings architecture, and that's really cool. Because, for example, right now we are migrating from the legacy architecture that we were using. We were storing all the embeddings and not vector databases, more traditional databases like Cassandra, for example, or ScyllaDB, etc. We are migrating into another type of recommender design, which is called the two-stage recommender design or the four-stage recommender design that is related to the building parts that you were mentioning. Like, for example, we will have a candidate retrieval phase and a rescoring phase, like a scoring phase, basically. The candidate retrieval phase will retrieve similar items to a given item from a vector database, for example, Quadrant or VB8, Pinecone, whatever you want. And then the scoring phase will take a very heavy, computationally heavy model like XGBoost or a heavy neural network or even a transformer architecture, whatever you want. And it will take all these candidates and it will score the candidates and take, let's say, the 30 top candidates, for example. So yeah, I really like that. The fact that we can work with embeddings and work with different inputs. Like, for example, in many recommenders, you will work with the picture of the image. In case you are dealing with clothes, for example, the picture of the sweater, and you can generate embeddings for that image. Also, the tagline, and the description of the product. You can embed all of that text data, and also the user preference, the user clicks. So you have multiple inputs that you can transform into a shared embedding space and start working with that. And I really like that approach. I mean, I think that the way embeddings reflect human semantics is really, really appealing, really interesting.
it's really cool. I totally agree. While you were talking, it just made me smile because I remember the latest video you just uploaded. This your find your celebrity.
Yeah. Sometimes I need to be like the Joker of LinkedIn,
No,
because
no.
otherwise it's very boring. And maybe I'm wrong, but I thought I had more resemblance to Keanu Reeves than to Andy Samberg, and it was like, oh no, don't tell me I look like Andy Samberg. But yeah, I mean, AI is right. I mean, vector space is right. And if my the embeddings of my face are closer to Andy Samberg, then that's it. I mean, it's objective.
It's fair enough.
I can't complain.
I'm more interested to see what I would look like. But I mean, from a project perspective, it's a very interesting tech that we can do something like that. So like, congratulations on building this project.
Yeah, maybe I need to talk about it a little bit.
If you want, yeah, feel free. I mean,
because maybe we are talking out of context, but basically the last project that I built using Quadrant, using the vector databases that we were talking about, and also the embeddings, was a twin celebrity app where you take a selfie of yourself, and we have like a CNN, like a convolutional neural network that transforms your selfie into an embedding and finds the similar vector in a vector database. And that vector database contains embeddings of each of the celebrities out there. And in my case, it appears that I look very similar to Andy Samberg, which, if you don't know, is the guy from, what's the name? Like Lonely Island and Saturday Night Live, and like
famous,
comedian.
Very famous comedian guy.
Yeah.
Very funny as well, I would say. Like,
yeah, very funny.
Yeah,
I like him. I really like him.
Yes.
Yeah.
Yeah. Now it's really, was there anything that was really challenging in this project that you didn't expect?
Maybe the generation of all the database of celebrities, generating the embeddings for each one of the images was a bit challenging. It took a while because you had to provide some memory, and the code could get really scrappy because you are dealing with different parts. And that finally I chose to work with ZenML for all the pipeline orchestration. And I think the code right now, it's really, really clean and maintainable. So it's really cool. I mean, I will be pushing all the code today, I think, tonight.
Nice.
So
looking forward to check it out.
Yeah.
Would you recommend ZenML as a tool?
Yeah.
Like, do you use it also in production?
Yeah, that's it. I use it in production. It has a very cool feature that maybe you also like it. They provide an abstraction, a concept called stack, and the same ZenML code, the same ZenML pipeline. For example, my embedding generation pipeline, in this case, can be deployed to Amazon, to Azure, to Google without changing a single line of code. And that's really, really great. I mean, they have like the translation under the hood of this component in Amazon resembles this component in Google and equivalent to this component in Azure. So that's really cool. Very cool.
That's very interesting. So, like one basically language, and then you can deploy to 3 different clouds.
That's it. Have a
very
common
powerful.
interface, and you can deploy to different infrastructures.
Nice.
So yeah,
That's really
cool.
Nice, man. When I invited you, I saw this really nice series that you did, which is a series about agents, of course. What I would like this podcast to be, which is something maybe a little bit different. I mean, we did this in the previous episodes where we did a super introduction to LLM security. So it was like an educational podcast, basically. And it was quite interesting. People liked it. So I would like to do something similar because I don't know about you, but like the rate of development of AI is getting super overwhelming, especially for everybody and also for us, like we work with this and still I'm getting overwhelmed. I stopped working with LangChain for maybe like 6 months. I was focusing on other things. I came back to it. The whole website is new, like the whole functionalities, Langsmith is there, agents are there, and
LangGraph.
I was like, LangGraph, oh my God.
LangGraph is there as well. Yeah.
Yeah. So it's getting super frustrating and super overwhelming. Especially also now we hear this multi-agent architecture and people want to experiment with it. People want to use it. I mean, it seems very interesting, the technology or what is possible to do with this tech. It takes some time to kind of wrap your hand around it because it's kind of like a different way to do things as we were doing it before. Walk us through a story. I would like a story maybe from the moment agents came out. I see in your series, you kind of put it into 3 different patterns, which also maybe came, if you look at the history of it, it's also was maybe chronologically correct because like multi-agents was kind of like the last stage of it. We started with like an LLM and then LLM with a tool and then multi-agents. Maybe walk us through like from the moment LLM came. I mean, not that far in the past, but
I don't know exactly all the all the history, but I can try.
Let's imagine like an LLM as like this one person, and let's start adding stuff to it, and let's see how it becomes.
I really like that metaphor. So if you want, we can start with an agent because it's like a very ill-defined concept because everyone is speaking of agents and no one has a clue of what an agent is. In fact, for example, I did all these Agentic pattern series. But if you take a closer look, you will see that I never define an agent. And that's intentional because I'm planning to do another series about what is an agent because I've been overcrowding LinkedIn with Agentic patterns and I've never spoken about what is an agent. So what is an agent? This is, of course, it's my definition. I mean, it's shared by many experts in the industry. And to cite one of them, I really recommend you to read one blog. It's for Lil Jen. I think it's her name. And she works for OpenAI, and she has a blog which has amazing articles. It's called Lil Blog, and she has an amazing article about LLM agents that I really recommend and encourage you to read because it's amazing. And I really like the way that she defines agents because it's by using a metaphor, very similar to what you were saying about an LLM and putting stuff on top. And I'm going to follow that path. So an agent is basically, it's a system where the LLM, let's say, can be understood as the brain. So you have the LLM and you start putting things on top and you arrive at an agent. So basic building blocks that you might find in any agent. So you'll have, as we were saying, an LLM as the brain and then the memory. And the memory can be like two types. The first one is the short-term memory, which sounds like really exciting, but it's just the dialogue in this case, or the context window of the LLM. And then you have the long-term memory. And for the long-term memory, generally, you store all of this long-term information in a vector database, for example. So that's something that you can exploit using RAG techniques. That's the long-term memory. That's things that are outside of the weights of the pre-trained LLM that the LLM can access from outside its weights, its training. Okay, so that's the memory part of our agent. Then we have the tool part. This is, for me, the most important. In fact, I remember Sam Withabin, I think it's his name. He's a content creator in YouTube, and he had an amazing phrase in one video. He said that tools are the agent's secret sauce. It's like the secret ingredient for any agentic system to thrive and to be successful. And I completely agree. Tools are ways for the agent to access the outside world. It might be an API, a weather forecast. It might be, I don't know, financial information, or it might be my Arduino, for example, or anything you want. And then we have a last bit of this agent, which are all the heuristics for planning and reasoning. This is something that was added after all the development of LLMs, and we have techniques like React, which is the de facto technique for every agent out there. But we have additional prompting techniques like tree of thoughts, chain of thoughts. Chain of thoughts is interesting because it's the technique that OpenAI used in the last Strawberry LLM, the OpenAI O1. They use chain of thoughts, but in the training phase. And chain of thoughts is basically that instead of you receive a prompt and you generate an output, you decompose the initial prompt into multiple thoughts, and you follow like a sequential process of reasoning. To recap, we have LLM as the core, as the brain of our agents, and we have the memory, short and long term. We have the tools that we need to define, and then we have all the planning heuristics. And that's basically what I conceive to be an agent. That being said, it's possible to have agents without, for example, planning techniques and without, for example, any tool. It's possible. It's just like a very simplistic blueprint that allows us to discuss about the same concept. But I mean, it's a very ill-defined concept. I would say that even artificial intelligence is a stupid concept. I mean, the idea of artificial intelligence is like, I mean, we all use that, but we don't even know what intelligence is. So what is artificial intelligence? But yeah, that's for another podcast.
That's
right. That's my some of my philosophical inquiries that I ask myself. Sometimes I feel like a fake, like AI engineer, but I don't know what AI is. So, and yeah, that's basically an agent. And if you want, we can explore like the 4 agentic patterns that I was defining.
I would love to.
We have 4 agentic patterns. The first one is called the reflection pattern. The second one is the tool use pattern. The third one is called the planning pattern. And the fourth one is called the multi-agent pattern, which right now, as you already said, is probably the most famous. It's also called flow engineering. If you see in LinkedIn, if you see in any article paper that they talk about flow engineering, it's basically the same as multi-agent patterns. So reflection pattern. Reflection pattern is the most simple, but still it generates really good results as opposed to a plain LLM. And what you do is you let the LLM reflect upon its own inputs. You create an agent that is composed of 2 components. One component is the generator, and the other component is like the reflector. The generator generates a prompt, and the reflector corrects and generates feedback for the generator output. And then all of this feedback is generated and serves as input for the generator again. So let's put an example. For example, let's say you are trying to generate summary or an article about what is an agent. The generator, this block of the reflection agent, generator is going to generate a first draft of this article. It's going to pass the draft to the reflection phase. And the reflection phase is going to take the draft and is going to say, well, this is very bad. You don't explain anything. Where are the bibliography, for example? It's very bad structure. So all of this feedback is sent back to the generator. And the generator says like, oh, okay, it was terribly bad. So let's change everything. He changed everything and then it's sent back to the reflection. Acts like some kind of teacher that is going to teach you and to correct all the output and tries to guide you through a better outcome. And we continue with that loop until you have like 2 options. You can loop for a number of iterations, for a max number of iterations, or you can loop until the reflection part says like, okay, this is perfect.
Mm-hmm. Is this very specific to agents? Because I've heard about this concept also in terms of like sometimes RAG systems or sometimes also just pure LLMs.
Pure LLMs, yeah. I mean, that's something that you can also apply to pure LLMs. Yeah, as I said before, it's a very like fuzzy ecosystem where it's difficult to really define things properly. And yeah, for sure, you can take, I don't know, Mistral, or you can take Claude and you can start reflecting. It's very, very simple to implement.
And a question will pop up in my head. Are these two LLMs trained the same way, or is this like critical thinker, feedback giver? Is this LLM being trained differently? Do you know?
Yeah,
By
you
any chance?
can, for example, in the applications that I've built that use reflection patterns, you can use different LLMs. For example, one LLM for the generation phase and another one for the reflection phase. And I've also used, it's typical to use different system prompts. For example, the generator prompt will be something like, you are a student who wants to generate a very good article about agents, and the reflection part will have a system prompt like, you are a teacher who wants to give advice and wants to give feedback to the student.
That's so crazy.
And you
that
start
this works.
playing with the, I don't know if you're familiar with the OpenAI API, the user role, the AI role.
The system.
You start playing with that all the time, because for the reflection phase, for the reflection block, the user input is the reflection output. And for the reflection part, the user input is the generation output. So you start playing with that all the time, and the results are really, really cool. And
when does it stop? When does this evaluation stop?
You can iterate for a number of iterations. You can loop, I don't know, like 10 times, 20 times, whatever you want.
Oh, sorry. Yeah. So the user, like the one who's programming the system, would define, okay, iterate for 10 times.
That's like the first approach that you can take, but I don't like that. What I usually do is to tell the reflection part to call off the process when it validates and evaluates the generated article, for example, and it's okay. There are no further changes to be made.
Interesting.
That's what I do.
They use the same thing. I spoke to a software architect who built like a RAG system that I told you about. And they used a very similar approach for evaluation, which seems to be like LLM as a judge, if you heard of this term, which seems to be so common. But I find it so interesting that two systems, basically models that are very similar, one would give an output and the other one would say, oh, does this output make sense? And then the LLM would say, oh, yeah, that makes sense. Of course.
I think like that there are tons and tons of articles about how to build proper LLM judges, because as you say, OpenAI models are going to be like more acceptable for OpenAI models, and maybe they criticize more Mistral models because it's not like the kind of embedding generation that they will expect. But yeah, typically, at least from what I've read, they are defining, people, all the AI engineers out there and all the intelligent people in Silicon Valley, they are defining like agnostic LLM judges, like LLMs which are not proprietary and that do not belong to any of these LLM providers, and that try to provide a very objective evaluation of the LLM. But as you say, it's really difficult, because how do you define what is objective in this case? They are just computing systems evaluating each other. So at the end of the day, I think you need some human in the loop. Something that's human feedback. And that's reassuring for us, because sometimes, I don't know if you work with Cursor or with editors like this.
Not yet. I want to. And I see it on LinkedIn everywhere. And I'm like, oh, and people are really pushing it on me. Like, you should need to try it, Serop.
The thing about this is that they are selling you all of these AI editors as like AI coding assistants. But at the end of the day, when I finish my day of work, I realize about my day, and it's like, who is the AI assistant here? Because I am the one who only changes like one line of code. It's like, who is the coding assistant? Because I'm starting to believe that Cursor is the one who programs, and I'm the one who modifies one single line of code. So it's terrible.
It sounds like you're having identity crisis.
It's a pure identity crisis. Yeah, that's it basically. Yeah.
Are we the AI assistant? I never seen it this way, man. You really ruined it for me. Oh my God. I will never program the same. Regardless, let's go forward. Let's go to the tool before this gets out of control.
That's it. So the second one is the tool use pattern. And as the name implies, it's really simple. It's just a pattern where the agent is going to have tools at its disposal, and he can use these tools. It can use these tools to access the outside world. And these tools are basically, for example, Python functions or JavaScript functions, whatever you want, but they are code that the agent, in this case the LLM, can interact with. Some API call, or I don't know, Wolfram Alpha if you want to solve some integrals, or I don't know, Yahoo Finances if you want to grab some information about NVIDIA stock price. I don't know, things like this. And possibly the thing that I enjoyed the most about the project that I made, the Agentic patterns from scratch, because it gave me the opportunity to implement from scratch a tool. Maybe, yeah, you said that you have worked with LangChain, maybe Llama Index and things like that. And they provide interfaces for the tools, pretty fancy objects and decorators for the tools. But at the same time, they hide you away from all the details. And when things fail, when you see that the LLM is not providing the intended output, it's really, really difficult to debug. And by building this from scratch, you suddenly realize that it's extremely simple. Tools are like people talk about like some magic things that the LLMs came up with, and they allow the LLMs to interact with Yahoo Finances, for example. And at the end of the day, an LLM is an NLP model. I mean, it's a language model that takes text as input and generates text, and that's it. And the only thing that you're doing with a tool is providing information about all the function, like the docstring of the function, the arguments, the return types, the Python type hints, all of this information, and you are putting all of that information inside the LLM input context. And then the LLM is going to return a string, because that's basically what an LLM is going to do, a string containing, for example, the arguments that you need to pass to the Yahoo Finances API, to your tool for Yahoo Finances. And that's it. I mean, it's as simple as that. And when I suddenly realized that, it was like, wow, I mean, many of these frameworks are just like glorified API calls, because it's like, wow, it seems to be very difficult, but when you get into the details, it is not. It's quite simple. Of course, I mean, they have a lot of very interesting code in all of these frameworks. I don't want to be mad at anyone. I mean, they are amazing, and they have a lot of interesting code for, I don't know, all the exception catching and things like that. And it's really cool. But conceptually, it's extremely simple. So that's tool use. Then we have the planning pattern. And by implementing this, if you go to the Agentic Patterns project, you basically implement many of the agents out there. Crew AI agents or LangChain agents, they are basically implementing a technique that I code from scratch in the project, which is called the REACT technique, which stands for Reason plus Act. And the REACT technique is based on three components. You have like reasoning, a thought, and then an action. You basically observe the environment. Then after the observation, you think what to do, and then you take an action. So yeah, and that's observation, reflection, and then action. And the cool thing about the REACT pattern is that it lets the agent decide among different tools. So for example, suppose you have one tool for Yahoo Finances, as we were saying, and another tool for integrals. For solving integrals, let's suppose it connects your agent to Wolfram Alpha. So what will happen is that if I ask, using my beautiful chatbot interface, if I ask my agent, hey, I want to solve this integral, how can I do it? Then the agent will immediately apply the REACT technique. It will observe your prompt. It will reflect that, what is this guy asking me? Is he asking me about NVIDIA stock price, or is he asking me about some integrals or mathematical computations? Okay, it's mathematical computations. Then I'm going to use the tool for Wolfram Alpha. And then it uses the tool, it grabs the output, and it observes the environment, which in this case is going to be the output, the tool. Like for example, 45 is the result of your integral. And then it will return the result to you.
And in this pattern, is it just one agent basically doing the planning, or is it like
That's
also
it.
multiple?
That's it. But that's a very good point, because the problem with this pattern is that you have one agent with multiple tools, and it can lead to very complex situations, very complex systems, because you have only one agent taking care of a lot of reasoning capabilities. And that's why we enter into the multi-agent pattern, because all the researchers realized that it was easier to have multiple agents but much more stupid than one agent, really intelligent, doing a lot of stuff and deciding which tool to use. So right now, the agents that are based, for example, in CrewAI, you will see that all the agents have a very specific task. Like one agent is going to write a poem, another agent is going to translate the poem into Hebrew, and the last agent is going to use a tool for writing the poem into a CSV, for example. So it's really specific, but they thrive in this because when you tell an LLM a very specific task, it's going to give it almost all the times. Instead, if you start asking about complex things and relying on heuristics with prompting, engineering, etc., it might fail.
When you say like a lot of more stupid models, what are we referring to? Is it like smaller models or models that are more specialized on a certain task, or what is the actual thing?
Yeah, that's it. Specialize on a specific task, and the consequence of this, of having much more simpler tasks, is that you can reduce the size of your model. So instead of having a GPT 4.0, you might have a Mistral 7 billion or something like that. Something smaller that can deliver the task because the task is much simpler than before.
Mm-hmm. Okay. And from my understanding, when you have this multi-agent approach, there's like the boss agent, kind of like they have different names, like the the manager, the coordinator, whatever. Is that also like the pattern? Is it like somebody has to delegate all the tasks to all the others, or is it usually they know what needs to be done? Like you throw a task and they kind of pick it up.
Yeah, so basically what you will have, there are like different architectures. Like, for example, you might have a hierarchical architecture where it's similar to how a business or to how a state is structured. You have like the president and then subdelegates and then the laid people. But yeah, at the end of the day, the multi-agent system needs to know the end goal, like the overall task, and each agent also needs to know the specific task. Okay, so that's basically how it works. In the implementation that I did from scratch, I orchestrated everything following a similar philosophy to Airflow, to Apache Airflow, where I define agents as tasks, and DAG is going to represent this group, this multi-agent system. So what I do is to simply define the different tasks for each one of the agents, and when the first agent finishes, it's going to send the context about its output to the next agent, and the next agent is going to take that context as input, validate or generate whatever it's necessary, and then send the output to the next agent, and so on and so forth. That's basically how it works. And at the end, it will generate like the final task.
Have you seen this actually working on like really important use cases where with the one agent with the multiple tools, this use case was failing, and then we switched to multi-agent, all of a sudden, like we were able to solve this problem? Or is it just something that were like people like, this sounds cool, let's just put a bunch of stupid agents and then let them solve it?
I think it was a trial. No, but I love the expression. I mean, I love it.
Oh, no worries.
I think it's like trial and error. And I think that when you work like a lot with LLMs, you suddenly realize that it's much better to generate very specific tasks, to task the LLM with very specific goals, because otherwise it's going to get crazy. And I think that given the huge amount of articles about tree of thoughts, skeleton of thoughts, algorithm of thoughts, someone said like, hey guys, we need to stop and we need to start thinking about something maintainable because this is getting crazy. I mean, we have a lot of different techniques that, I mean, they are not scientific in the sense that, they provide a lot of evaluation, a lot of prompts, examples, etc. At the end of the day, I mean, you are doing alchemy, to be honest. So they decided to go to the basics, like a very simple task, but multiple agents. And let's see how it goes. And if you see like the success of frameworks like CrewAI, AutoGen, LangGraph, OpenAI Swarms, which is hitting right now really, really hard, I mean, it speaks for itself. So it seems like we have a winning pattern right now. I mean, I need to mention that each one of the agents in this multi-agent fashion, it's a React agent. I mean, they are taking something from another pattern because they know that React technique is probably the one that works better in the most situations.
Interesting. You know what I find really bizarre, or not bizarre, but like really interesting? In machine learning, we started from smaller models, very specialized. You do very specific tasks, like, I don't know, computer vision for facial detection. It will detect your face, but if you tell it like detect my gender, it will fail. I mean, probably it would fail now anyways, but But like if you give it another task, like get something else, it will also fail. And ChatGPT was one of the first things that came out that was like one model solved so many things for you. Like also now started to add images, multimodal, audio, all this thing is in one head. And it's interesting now that we're going back to machine learning where you focus more on like smaller models and then build systems that are more specialized.
And look at all the recent development from Meta, for example, to generate models that can be embedded into edge systems like mobile phones, Arduinos, security cameras, So that's also a very interesting development in the community, not just reducing the size of the models to make them efficient, but also to try to implement all of these models into the edge without relying on the internet. So it's really, really interesting. And I understand your point that we are like going backwards, but for me, it's the way to go. I think machine learning systems were really good, as you already said, in specific situations. And I believe that the success of ChatGPT has to do, of course, it's an amazing model. I mean, for me, it has the same impact as the internet, close to the internet. I mean, it has a huge impact. We were talking about AI 5 years ago, you and me, probably, but now, I mean, I go to the pub in the corner and they are talking about ChatGPT, about AI, about diffusion models, about a lot of this stuff. So it's amazing the impact that ChatGPT and GenAI in general has in the overall world. But at the same time, I think that the impact has to do with how our mind as human functions, in the sense that many times if you see what people are trying to generate are essays, are articles, poems, songs, which are things that they are easy to generate and to make the human happy, but when you try to build something for proper evaluation, you need to request in an API, or you need to talk with a specific machine with a specific protocol, and you need to do all of this using LLM. Suddenly you find that they are not as reliable. They are really reliable when you generate an essay or when you chat with a human, for a general conversation and funny conversation. But when you get into the real stuff, like the productive stuff, then I think we start to see all the fails in this approach. And that's the reason why I think we try to make it more specific and more tailored to the task.
Interesting. What is the stuff that start to fail? Like, do they start calling these functions with weird parameters? Do they start hallucinating? Yeah. Do they pick up the wrong tools? Like, what did you observe?
That's it. Like, for example, imagine you generate an agent that has to deal with a SQL database and also to call in an API and also to launch in Apache Airflow jobs. It's almost certain that at some point it's going to fail because it's going to maybe generate the wrongly format SQL statement and it's not going to work when it runs in the productive environment, or maybe it generates, as you were saying, some invalid params. It figures out some param that it's not defined on the API, and then it's going to fail. Or maybe, launches a job and it forgets that it had to add a service account to be correctly run in Google Cloud. A lot of different steps that if you generate a specific agent that only takes care of Airflow, it's much more probable that it's not going to happen. Probably you will get rid of all of these nasty situations, that really impact the production environment.
Mm-hmm. Have you heard any stories about people putting these systems in production or any interesting use cases?
Yeah, I've had bad stories about people deleting, for example, all the databases all the tables in the databases, because one thing that you need to understand is that you need to take precautions. This is not a general AI or a super intelligence. It might generate crazy statement that deletes everything, and that's the reason why you need to attach service account or credentials that really limit the potential for havoc in your databases. And that's something that, students of a master degree I did 1 month ago told me that they tried to build typical how to LangChain agent for SQL databases, and it turned into a nightmare because it deleted everything.
Yeah.
So, yeah.
That's and these things are not so uncommon, by the way.
No, they're not.
The problem is usually you try to defend yourself from outside invaders, because it's like SQL injection. People try to delete the databases from the outside, but now you have something that is could do such a thing also from the inside. So yeah, guys, use your mind. Don't give the whole planning to the LLM. Like use like
completely.
engineering best practices.
Yeah, I mean that's it. I mean, I think you made the point perfect. You are called AI engineer or ML engineer for something, because if you start delegating everything to the agent, okay, then you are a perfect assistant, and you are very good at clicking the button, the play button, and just waiting until everything crashes, because it will eventually crash, at least at the current state of the technology. I don't know, in 10 years, 20 years, maybe you and I are, I don't know, in the street begging for mercy or something. But I don't know.
Could be.
We don't know.
Getting mercy from our AI overlords.
Well, that's it.
But hopefully they will look back and they see like we were kind of promoting them, and I don't know, trying to be nice to us.
That will be nice.
Okay. Before we close, is there any parts that you think we missed and you would like to add?
No, I think it was really complete, and I really like the fact that you had put so many interest in the production state of all of this. Like sometimes you see a lot of people who only talk about the good parts of the LLMs, like how amazing, how beautiful they are, but there are a lot of bad things that we need to address, and mostly in the production environment. Because many of these frameworks, for example, I mean, they are amazing, but I'm not completely sure if they fit 100% productive environment, like LangChain, even CrewAI. This is probably really polemical right now, but I think I'm not sure if they fit a production environment, to be honest. For example, LangChain hides away a lot of the prompting that they are doing under the hood. And sorry for this, guys from LangChain. The library is amazing, but it's hard to work with things like this in production, not knowing the prompts that you're generating, even if you put some evaluation metrics, some Comet ML, or things like that, to really check the prompts that you're generating, all the cost that you're incurring. Even so, I don't really like using so many layers of abstraction in production.
Yeah, and you're not alone in this. I've heard this comment so many times from people actually working with it, whether they are freelancers building stuff for like actual production layer. Some of them were really impressed with what is it called, like Langsmith, like the tracing that they did, so you can actually really see what went bad.
That's amazing.
So
amazing.
Yeah. They said like this actually worked, but other startups, they say like, no, it's a nightmare. So they decided to write their own wrappers around everything. They thought that time investment was even better than debugging the whole thing.
Yeah.
So there's
Llama
like conflicting.
Llama Index is I don't want to, it's like deciding between your mother and your father, but Llama Index has a really clean, infrastructure interface. It's really, really cool. I really like Llama Index for that, because LangChain, as you said, that you stayed like 6 months away from all these GenAI frameworks, and when you came back, everything has changed, and that's not ideal, for development.
No, that's bad. Yeah, it's
really bad.
I needed like to be kind of onboarded on so many different things. But the problem is also the industry is crazy. Like the industry is evolving in such a rate that is making everybody so tired to be on top of it the whole time. One of the most good performing articles I ever read was something super basic. It was about how to stay up to date with ML topics. And I just told people how to do like RSS feed and connect it to their feed reader. And then you can get the articles from like important blogs, like, I don't know, Google blog or whatever. And people, why people liked it? Because everybody's so overwhelmed with all these news and all these tools. And especially now, there's uncertainty about the job market. People don't know where to go. Seems to be AI engineering is the only jobs out there at the moment. So it's also a bit crazy. But
yeah, and they turned you into a AI engineer, even if you don't even know what is that, because right now they are calling me AI engineer, and I guess I'm that, but no one really, because sometimes I ask in the comments when people ask about AI engineer, but it's not, to be like picky, and it's just because I'm interested in what is AI engineering, and I ask about it, and I only get like contradictory answers all the time. Like, no, it's the guy who works with pre-trained models. And it's like, I'm an ML engineer and I work with pre-trained models. And it's a guy who calls APIs from LLM providers. It's like, is that AI engineering, really? Calling APIs? I don't know.
I also agree with you. We went to this loophole also a couple of years ago with the whole ML ops thing that came up. because we needed people to put models in production, and then there was MLOps, and then there was like, I don't know, analytics engineer, and just fancy terms. As long as you know what are the tasks and can you do them or not, I don't give a shit what people call it. It's just like we can do it.
I love that philosophy. That's my philosophy as well. I really love it. I mean, you need to put things, create AI systems that work, that provide some value to your potential customers or to the company that you work for. And that's it. I mean, that's your job. Whether you want to call yourself MLOps engineer, AI engineer, LLM engineer, or ML engineer. I mean, it doesn't matter.
Yeah, I agree with you. All right, Miguel, this was a very insightful talk. Thank you so much for teaching us about agents and the whole patterns that we have.
The pleasure was mine.
And I will definitely keep watching your awesome videos and wish you all the luck.
Thank you very much, sir.
Thank you, Miguel.
Thank you very much.
Take care. Bye-bye.
Take care. Bye-bye.